Hey everybody. Imagine you're on a job as a consultant and you're with a client, and the client asks you, could you provide us with something that helps us orchestrate our container deployment? It needs to be scalable and it needs to be secure as possible. We don't want to use Kubernetes. Actually, we saw something from a company called Hashi something. And we all want the code in a Git repository. Well, that was my situation at one point. I already knew HashiCorp from their product called Terraform, but I didn't know the rest of the toolkit yet. I went to their website and recognized some of their other products like Vagrant and Packer and browsed through the documentation and found a tool called Nomad. Nomad is a workload scheduler and seemed very suitable for the job since it can schedule container deployment and it's suitable for microservices and it's highly scalable. While reading the documentation, I came across several references to another HashiCorp product called Consul. Consul is a service networking solution and enables you to be able to do service discovery and also service mesh solution. It kind of made sense that I could use this in combination with Nomad to benefit the scalability and the flexibility. Okay, now we got the networking part covered, we got the application part covered, and the only thing left now was security. I'm sure you can add encryption to Nomad and to Consul, but I needed a way to use sensitive data within this environment. So I read up on another tool in the HashiCorp toolbox called Vault. Vault is a secrets management tool that enables you to work with sensitive data in a secure way. It works with Nomad and it works with Consul, and it's also very scalable. With all of this, I think all the boxes are ticked now, so we can begin our work. So there I was at the client trying to integrate these three products together. The time span was short, so I had to do a quick deployment. It had to be on premises, and we had to use a setup where we can reuse the code to deploy multiple environments. But there was no really a complete integration guide. There were guides that were guiding you for specifics on Vault and on Consul and on Nomad, but no complete integration guide to mesh them all together. So many hours later, many cups of coffee later, even more lines of code later, and really lots of redeployments later, it finally worked. And it only took me 2 months. So how did I achieve this? Well, I used Ansible. Ansible is a configuration management tool that allowed me to deliver a predictable environment and where the code is idempotent. It's modular, and apart from fitting in some variables up front, it's pretty much zero touch. But then I came up with the idea, why don't I share this with you all so you don't have to figure it all out on your own? I'd include a way to deploy this in the cloud by using Terraform. Terraform is a tool that allows you to do infrastructure as code. And on the other hand, to do this deployment locally on your local desktop or your laptop by using a tool called Multipass, which simulates a cloud environment with local VMs. This all is shared in a repository, and I will share a link to this repository at the end of this session. Hi, and welcome to my session on how to deploy your Hashi stack with Ansible in under 50 minutes. My name is Chris van Meer, and I'm a consultant and trainer at AT Computing. It's a company based in the Netherlands, and we teach our customers how to use open source software, and we help them with implementing them. My day-to-day focus is mainly on Ansible, networking, and on the HashiCorp portfolio. Also, am I a co-organizer for the Amsterdam HashiCorp user group. In this session, I will show you how we can use Ansible to deploy and provision a stack of Consul, Vault, and Nomad. To demonstrate this, we are going to build an environment and integrate these products together. We will then deploy a high available stateless web app, which is load balanced. It's running on TLS and it's in a server setup, no dev mode. This all is running on my laptop with the help of Multipass. And a little bit of disclaimer, be sure to use this as a reference point for a demo or a test environment. In a production environment, you probably don't want to combine the server roles like I did. In a production environment, you'll probably be running Nomad and Vault on a Consul client node. And please be safe with distributing the sensitive data from the output from all these applications. Okay, so what are we actually going to build? We are going to build an infrastructure that houses 7 instances. 3 of them will be servers, which will be running Consul, Vault, and Nomad in server mode. And 4 of these instances will run the Consul, Vault, and Nomad binary as a client. Client 1 will be our reverse proxy by using traffic, and the other clients will have the web app deployed to it. Okay, let's start the demo. And as with this presentation, the rest of the session will also only feature command line. So bear with me. The first step is to do a general deployment. We'll instruct Multipass to deploy some instances, and we'll have it create an Ansible inventory, and it modifies the local host file so we can easily connect to the service. After that, we will be running another playbook to install the HashiCorp repository, install the binaries. On the clients, there will be Docker installed. On all nodes, we will be using DNS mask. So that's that. We'll use several pip packages for Ansible to connect to Vault and Nomad, and some basic packages that we'll be using in the demo. Okay, here I am on my laptop, and the first thing we'll do is to clone the repository. We'll move into the directory, and we will see here an Ansible configuration file, and if we look at that, it will expect an inventory file as specified as the file called inventory, which is not present right now. And if we do an Ansible inventory with a list, there's nothing visible. To verify up front, we have nothing in our host file. And when we look at Multipass to see if there are already instances running, those are not. So the first playbook we will run is the one that prepares the hosts for us. And I will pause the video here and come back to you when this is done. And we're back. As you can see, this has roughly taken us 3 minutes to run. We need to rerun this playbook with a tag host file. This will now populate the host file. As you can see here, we have a managed block by Ansible. And if we do an Ansible inventory list, we will now see the instances that are created. And a multipass list will also verify that 3 servers and 4 clients are up and running. Now we need to do another playbook which will install all of the binaries. And here it goes. Okay, I paused the video for a moment, and this playbook has also been completed and took about 4 minutes to complete. So I saved you all 7 minutes of awkward silence. So next up is the public key infrastructure. And this will create a self-signed certificate authority. We will be distributing the CA certificate to all the servers and clients, putting them into their trusted stores so we don't have any issues with Vault, for instance, saying it's insecure. And it will create a certificate for our web app we will be using later within traffic. That is done. And if we go to the server and we do a grep on AT computing, we'll see that we have some different types of certificates here. We can use OpenSSL to verify some of these. And you have the issuer here is our created certificate authority. And we have our web app. Of course. Our web app certificate. And if we go to the trusted store, you'll see here that the AT Computing CA certificate is present. Next up is Consul. So this will create a Consul CA and will create a server and client certificates along with an encryption key. Consul will be bootstrapped and the token is saved on my laptop locally. There will be several Consul policies that will be created, and we'll modify the default Consul policy to allow DNS lookups. And then after that, the CNI plugin is installed. And that's about done now. So if we look here, this is the place where the Ansible scripts do save the initial configuration. We'll have a management console token. And if we go to the server, we'll see that 8500 is listening. And we can verify that we have a data center called Velp. And we have one service, which is Consul. We need to verify if DNS mask is also working. And you'll see here that it is working. So that was Consul. Next up is Vault. And this will create some TLS certificates for the Vault nodes. And it will be signed by our CA Vault is configured to use Consul as a storage backend. So for it to be able to create the needed KV store, we create a Consul ACL, and we then will initialize the first server Vault. We'll unseal it. We'll create an admin policy, create an admin user, and we'll revoke the initial root token. It will enable the KV2 secrets engine. It will enable log rotate, since Vault doesn't have a real log rotate option included. I created one with log rotate, and then we'll enable file auditing. So that's done. If we do a curl on localhost on the console port, and we'll do a check on Vault, we'll iterate through that, and we only want to see the status. We have 3 servers, and 3 health checks of these servers are passed. We have a new service called Vault. And we'll see here that it's running on 3 servers on the port 8200. If we look up active vault.service console, we'll see that this is the active node now. And we'll try to log in into into Vault. But we need a token for that. We'll use this one. And this doesn't work. I did it intentionally. The root token has been revoked. So we'll use this one. Now we create an admin user. And now we are logged in into Vault. So you can see here the storage type for Vault is Consul. It's HA enabled, it's initialized, and it's unsealed. If we do a Vault auth list, we'll see that the user pass has been enabled. It's the user we're running with now. Vault secrets list, you'll see the KV secrets engine being mounted at the path of secret. If you do a KV list secrets, and there's nothing there. We can also verify that auditing is enabled, and it's enabled at file level. If we do a quick look at this, is the way I use to rotate the log files of Vault, and it will rotate every 7 days. So that's a Vault cluster up and running. Next up is Nomad. Here Nomad will be deployed. We'll create a policy for it in Consul. It will create a Consul ACL token for the Nomad servers and the clients. Nomad will be bootstrapped, and the token will be saved on the workstation. and the token for an operator is created. And that is done. Let's head over to the server to verify what we just did. We will see two new services appearing, and that is called Nomad and Nomad Client. We will verify by the Consul API. These are the checks for Nomad, and these are the checks for the Nomad client. Now, for a Nomad server, it's usual to have 3 health checks. One for HTTP, one for RPC, and a serve check. And the Nomad clients all have just one HTTP check. If we do a lookup on the operator token for Nomad, because right now we don't have any permissions, we'll see here the servers, the clients, and there are no jobs currently running. So now we have 3 of these products running, and it's time to integrate them a little bit more. We have a Nomad and Vault integration first. What this does is it creates a Vault policy for the demo app, and it creates a Nomad server role in Vault so that the Nomad servers can ask Vault for the secrets, and it places the web app certificate within Vault. This is done. Onto the server to verify. You'll see here that we have an SSL certificates policy, which will allow us to access the KV secrets engine. We'll have a Nomad server role that allows us to access Vault and issue tokens. We'll have a secret that is of course that's not read, but it's a get. And this is our created certificate. For the last part of our demo, we'll be launching our demo apps. And what this does, it creates 2 Nomad jobs and places them on the first server and then runs them. And here you see 2 jobs running. The AT demo job, that is the web app, and traffic is our reverse proxy. We'll look at traffic first. We'll see that it is resolvable. And you see that it is deployed once. And when we have a look at the logs, you'll see here that it is loading its configuration, and you'll see some request to the path of ping, which means it's up and running. And if we do a inspection of the demo job, we'll see here that it is creating a traffic job with a constraint. And this constraint means that it will only be deployed on one specific node, a Nomad node, with this unique ID. And this is the ID of client 1. Then we'll define some ports, and we'll create some templates for the configuration file to set some defaults, some middleware rules, and then we'll use dynamic templates for creating the certificate files and retrieving them from Vault. So now that traffic is up and running, we'll have a look at the web app. The web app is also running with a constraint, and this constraint tells us to run it everywhere except the first client in this case, and then publishing it to traffic by the means of traffic tags. And here below you can see that we're passing some environment variables into the config image, so that will house some default information of the host. You'll see here that it is deployed 3 times, and it should be also resolvable on 2 URLs. This is the Consul DNS record, and we also created a demo URL. This is pointing to the reverse proxy. Looking at the reverse proxy, we can access details through the traffic API, and we will look at that now. So the traffic API is running on port 8081. And if all is well, we'll see that it is defining a router with the same URL as above. And it also should have defined a service which has 3 endpoints. And if we now launch a command line browser, we'll see that the instance is up and running. And if we do a Ctrl R to refresh the page, you'll see that it is moved between the 3 nodes, which is traffic part of load balancing. So that is working. And we have 3 servers now for this job. But what if we want to scale this job to, let's say, the double of the count? Well, we can easily do that with a job scale command. And we'll scale it to 6 in this case. And if we'll verify the same command here, you'll see that it has now 6 servers. In the end, we now have traffic that is registered within Consul, and it retrieves the TLS certificate from Vault, pulls a container image, registers itself with Consul, and uses traffic tags. And as you saw earlier, we can quickly scale this to fit the need of the customer. So what I've built in this session, we created a local infrastructure that runs an integrated HashiCorp stack. We delivered content to the platform by the means of a web app. We created an environment which you can quickly use as a test environment, or that you can use as a demonstration for at work. And we had some CLI fun. If you want to look at the repository and clone it, you'll also find this presentation there. And if you need to contact me, there are several options here listed. So that's it for me, I think. Thank you for your time and enjoy the upcoming talks. Stay safe.